Hey guys, here we are for part 2 of talking about plants and animals and how those things that are created by plants as a response to the stimulus that we talked about yesterday can be used in our environment. So you're going to be using the handout that looks like the one on the screen. And the first thing I want to remind you of is that plants create glucose using energy from the sun through that process of photosynthesis. And today we're going to be talking about compounds that are produced by living things, especially those produced by plants. As you all know, this is the periodic table of elements. These are all of the things on their most basic level on Earth, whether they are living things or non-living things, they're all made of elements. And elements, the very smallest piece of an element is an atom, right? And atoms make up molecules, right? And molecules are compounds. Compounds are made up of more than one type of element, right? And glucose is a type of compound. And we're going to be talking about two main types of compounds today, organic compounds and inorganic compounds. So it's important that you remember what elements are from 6th grade and what a compound is. Remember, a compound is made up of more than one type of element, okay? So if we have more than one type of element, we have a compound. And there are two main types of compounds, like I just said. There are organic compounds and there are inorganic compounds. In our notes, we're going to use green and orange to represent organic and inorganic compounds. So when we talk about organic compounds, we used to say that organic compounds were derived or they came from living things like plants and animals, and that is mostly true. We used to say that inorganic compounds do not come from living things. And these are mostly true, but in science, we want to be absolute true. And so we, over the past 50 years, have changed the meaning to be a little bit more specific. So the meaning that you're going to need to remember is that organic compounds have the element carbon in them bonded with a hydrogen. So that carbon and hydrogen are bonded together in a compound. That's what makes an organic compound. So when you think about lots of compounds that you interact with on a daily basis, they are organic compounds. Now, inorganic compounds also can have carbon or they cannot have carbon, but the carbon is not bound to a hydrogen. So it can have carbon, it can have hydrogen, it just can't have both of them together if it's an inorganic compound. Organic compounds have carbon and hydrogen together. Inorganic compounds do not have carbon and hydrogen together, right? The lack of carbon-hydrogen bonds is what makes something inorganic, okay? Now remember, there are other elements on the periodic table. Remember that periodic table I showed you guys, right? There is chlorine, and the symbol for chlorine is a capital C and a lowercase l. Don't get confused when you see that Cl. When we talk about hydrochloric acid, the chemical formula for that is H, capital H, Cl, like you see on your screen in red. This is hydrochloric acid. It's found in your stomach. It is not an organic compound, okay? It has carbon, not carbon. It has hydrogen, but it does not have carbon, so it is not organic, right? In order to be considered organic, it has to have both, right? And this is where that old definition and new definition come into play, right? We want to make sure that we're clear. If it is an organic compound, that means it is a combination of carbon and hydrogen atoms bonded together in a molecule. All right, so glucose is a common example of a organic compound, and carbon dioxide is a common example of an inorganic compound. So you can see in glucose, we've got that C6H12. You see that C and that H that are together? That means it's organic. It's got carbon, C, and hydrogen, H. Carbon dioxide, it's got carbon. So does that mean it's organic? What is it missing? It's missing that hydrogen, right? So it has to have a carbon and a hydrogen to be considered organic. So it does not have the hydrogen, so it is inorganic. In just means not, right? It's not organic. So if we look at this chlorophyll, is it organic or inorganic? Look at the chemical formula. What do you see? Do you see a carbon and a hydrogen together that make up chlorophyll? Yes, you do. Chlorophyll is organic because it has carbon bound to hydrogen, right? That's C55H72. They're bonded together in that compound, in that molecule. They're connected, so it is organic. What about salt, sodium chloride? Is it organic or inorganic? Well, do you see, I see a C. Does that mean that it has carbon? Well, that's a Cl, and that's the symbol for chlorine, not carbon. It is inorganic because it does not have carbon or hydrogen bonded together, right? There is no hydrogen-carbon bond in NaCl, sodium chloride. What about water? We all need water to survive. Is it organic or inorganic? It has hydrogen. Does that mean it's organic? It does not have carbon and hydrogen. It only has hydrogen. So water is inorganic, okay? Caffeine, organic, inorganic. You got it. It's that carbon and that hydrogen bonded together, so it is organic, okay? Methane, that's what makes up cow farts. Is it organic or inorganic? It's made by a living thing. Does it have carbon and hydrogen? Yes, it does, right? It's carbon bound to a hydrogen. Literally, it's only carbon and hydrogen, right? So it is organic. When you see an uppercase C, that is a chemical symbol for carbon attached to that chemical symbol for hydrogen, that capital H, it must be an organic compound if they are bonded together. If you do not have a carbon-hydrogen bond, meaning you only have carbon or you only have hydrogen or you don't have either, that means it is inorganic, right? It is not an organic compound. It has to have carbon and hydrogen bonds to be considered organic, okay? That's the end for today. You guys got off the hook easy today, so I hope you have a fantastic rest of your day.